If the two or more molecules having same molecular formula but different structural formula, we say it is isomers, and the phenomena we call it as what? Isomerism. The s and p orbitals will not have a same equal energy. In order to make its energy same, they undergo hybridization or they undergo overlapping. You are vomiting the bonds and you are writing the structure of the given compound without any bond. Such structure we call it as what? Condensed structure. Hello my dear students, a warm welcome you all. Myself is Purnima, lecturer in Department of Chemistry at Vidhyaashram Pre-University College, Temple of Excellence, Mysuru. My dear students, in this session, we are going to discuss with the new unit in your first PUC chemistry, that is organic chemistry, some basic principles and technique. Before going to discuss with this unit, let us see the weightage of this unit. So from this unit, we can expect around 11 marks, and there is a one mark question, that is question number 9, and we have two 5-mark question, that is the question number 35 and 36 will come from this unit, and totally we can expect 11 marks from this unit. And it is one of the basic unit in your organic chemistry, that is on the first PUC. Okay, so in first PUC you have mainly two core chemistry topics. One is some basic principles and technique, and the unit is hydrocarbon. When you enter to the second PUC, you have 4 core subjects in a second PUC as for the organic part. Okay, all the 6 units, which has been prescribed by the pre-university board, which is very important for your competitive exams. Let us see what we are going to discuss in this session. In this session, we are going to discuss with the introductory part of the organic chemistry. In addition to this, we are going to understand what is the versatile nature of the carbon, and we are going to understand the shape of the organic compound and structural representation of organic compound and 3-dimensional representation of organic molecule. So first, we will understand the introductory part of this unit. We all know that when I am talking about the organic chemistry, whatever the compounds you prepare, it is mainly from the plant and animal sources. So in earlier days also, most of them, they know that the compounds which we prepare, it is mainly from the plants and animal sources. For the first time, the F. Uller, he is the first person, he synthesizes a urea from the inorganic compound, that is ammonium cyanide. So that is NH4CNO, which is ammonium cyanide. Upon heating, he come to know that he got an ammonia. This is one of the organic compound. So he is the first person, he prepared the urea in the laboratory by using inorganic substances. This was brought about the greatest advantages in the field of organic chemistry. Later on, the many scientists, they started preparing an organic compounds in the laboratory itself. Later on, the synthesis of the acetic acid by a coal base, which was brought about a major contribution in the field of organic chemistry. And the Bertland, he also showed that how to prepare a methane, okay, from the respective inorganic substances, and this shows that the organic chemistry is one of the greatest branches in the chemistry field, where you can study or you can synthesize many organic compounds which are containing carbon and hydrogen. Organic chemistry is the branch of chemistry that deals with the study of the compounds which are containing carbon and hydrogen. Okay, we say it as organic chemistry. So, who is the scientist who brought about the greatest contribution to the field of organic chemistry? The F. Uller was the first person. He synthesizes the urea from the inorganic substances. Later on, many scientists, it may be Bertland or it may be a coal base also. Later on, many scientists, they have started synthesizing the organic compound. Thereby, if you believe or not, now if you see that 5 million organic compounds which is already synthesized by the different scientists. At the end of every year, they are going to synthesize 30,000 new organic compounds. Okay, this was one of the interesting field in the chemistry. Okay, next is the versatile nature of carbon. So, when you are studying about the organic chemistry, it is necessary to understand why the carbon it looks different from the other rest of the elements. So, that we call it as versatile nature of carbon. Okay. So, when we are understanding the versatile nature of the carbon, three things are necessary. One is the tetravalency nature, second one is catenation, and the third one is isomerism. All three characters that you can see only in the carbon in the periodic table, and it is different from the other rest of the element. It is different from the other rest of the element. Let us understand what is tetravalency. We all know that the carbon has 6 electrons, correct? So, I will write the electronic configuration first. So, it is 1s square, 2s square and 2p2. Correct? Now, if you see that the 1s square which is present inside the, imagine this is a carbon, I am writing the atomic structure of the carbon, okay. You can see that this is my K and this is my L shell, and the K shell consists of only 2 electrons, whereas a L shell which consists of 4 electrons, correct? So, 2 plus 2. So, this indicates that in the outermost shell, it has 4 valency. So, carbon has how many valency? 4 valency. Due to the 4 valency which is there in its outermost shell, it will share all the 4 electrons with the other atom, thereby it forms a covalent bond. So, this nature of providing or sharing its electron, since it's sharing 4 electrons, which is we call it as tetravalence of the carbon or tetravalency nature of the carbon. So, hope you all understood. We are writing the electronic configuration of the carbon, and in that we come to know that in the outermost shell, that is on the L shell, it consists of 4 electrons, and that too that 4 electron, either it will not accept the electron, either it will not give the electron. Instead of this, it will share all its 4 electrons with the other atom, thereby it forms a covalent bond. This type of sharing 4 electrons which you can see only in the carbon. Hence, this nature we call it as what? Tetravalency. Okay. The atomic number of the carbon is 6 and the electronic configuration is 2, 4. That is, it has a 4 valence electron. Thus, the carbon has a tetravalent. That is, it forms a 4 covalent bond with the other atom. So, you can see that this is a carbon having a 4 valency and this is an alkane. Okay. I will write with one more example. This is a carbon atom which is forming 4 bonds, and this is one more carbon atom having a 4 covalent bond. This is an alkene. Similarly, you can write it with the alkynes also. Okay, you can see that this carbon atom and this carbon atom has a 4 valence electron, okay, or 4 valence bond. Hope you all understood with the tetravalency nature of the carbon. Let us understand with the catenation. So, it is one of the another versatile nature of the carbon. So, we know that catenation means it is the self-linking ability of the carbon. We all know that the carbon has a 4 valency, correct? So, it can link with the other carbon atom and thereby it forms a straight chain. Suppose if the carbon atom bonded with the other carbon atom, it may lead into the branched chain. Sometime, the carbon atom, they combine themselves and results in a formation of cyclic ring also. This possibility of self-linking ability of the carbon, we call it as what? Catenation. Remember, the catenation which we can see only in the carbon. Understood? So, the carbon has a self-linking ability, with the other carbon atom. Thereby, it can form a straight chain, it can form a branched chain, or it can form a cyclic chain. So, this nature of the carbon we call it as what? Catenation. So, the carbon has a strong tetravalency to undergo catenation. This property of an atom of an element to form a covalent bond among themselves to form a a chain molecule which includes straight chain, branched chain as well as the cyclic rings. We call it as what? Catenation. Okay. We have one more property, that is isomerism. We all know that isomerisms are nothing but the compounds which are having same molecular formula and same structural formula, but they are differ in a physical and chemical property. So this is known as what? Isomers, and the phenomena which is known as what? Isomerism. I can write with an example so that you will understand how to write with the example of isomerism of carbon. So example is C4H10. So how many carbon atom we have? 4 carbon atom. And each carbon atom has to be satisfied with a 4 valency, correct? So now I am writing a hydrogen atom to show that each carbon atom is forming 4 covalent bond. This is C4H10, correct? Next. So I can write this molecular formula in another way also, that is 1, 2 and 3. This is C4H10. You can see that in these two examples, I have written a compound in such a way that these two compounds are having same molecular formula. But you can see that their physical and chemical properties are totally different because they are structurally different. Such compounds we call it as what? Isomers, and the phenomena we call it as what? Isomerism. You can see that this is my straight chain having 4 carbon atom and with a 10 hydrogen atom. This is also having 4 carbon atom with a 10 hydrogen, but it is a branched one. So this shows that if the 2 or more molecules having same molecular formula but different structural formula, we say it is isomers, and the phenomena we call it as what? Isomerism. So this indicates that the carbon, it is being versatile from the other rest of the element. Why we call it as a versatile nature? Because of the 3 distinct character. One is tetravalency, one is catenation, and another one is isomers formation. Now let us understand the shapes of the organic compound, or it is a nature of bonding in the carbon atom if it is undergo hybridization. Okay, the hybridization influences the bond length and bond enthalpy in the organic compound, and the shapes of the organic compounds also I have written. If the carbon is sp3 hybridized, the shape of the carbon is tetrahedral. If the carbon is sp2 hybridized, the shape of the carbon is trigonal planar. If the carbon atom is undergo sp hybridization, we call it as a linear structure. To understand this, we will take an example of alkane, alkenes and alkyne, and let us understand why it is called as sp3, sp2 and sp hybridization. Okay, I will go with the writing part now. So, I will go with an example of alkane. Okay, the first member in alkane is methane, correct? Methane. So, what is the molecular formula for the methane? It is CH4. In this, write down the electronic configuration of the carbon. It is 1s square, 2s square and 2p2. Correct? If I want to express the 2s and 2p, because the 1s orbital which is having a 2 electron which is not involved in a bonding because it's an inertial. Now, I am going to write the 2s and 2p, how much electrons will be there. Okay, so that is in ground state electronic configuration. Electronic configuration. So, how do I write? So, the 1s orbitals will be written like this, and the p orbital should consist of 3 atomic orbitals. So, this is s and this is p. Now, look at the electrons. So, the s orbital has 2 electron, whereas the p orbital, it has 2 electron. Correct? So, according to the Pauli's exclusion principle, as we know that we have to fill the atomic orbital in a increasing order, then we have to fill up with the remaining electron. Okay? You can see that the methane has 4 hydrogen atoms. Correct? 1 carbon atom and 4 hydrogen atom. At the same time, if 4 different hydrogen atom approaches to the carbon atom got excited. When it is excited, the electronic configurations will be differs. We'll see how do we write. So that is in excited state. So how do we write the electronic configuration? This is my S and this is my P. Look at the board now. In the excited state, when 4 different hydrogen atom approaches, one of the electron from the S orbital got shifted to P orbital. Thereby, it occupies the 4 electrons in each atomic orbital. We know that the S and P orbitals will not have a same equal energy. In order to make its energy same, they undergo hybridization or they undergo overlapping. When they overlap, the hybrid orbital we get. So, S and P, if you write it, so one S will be there and how many 3 atomic orbitals will be there? 3. So, it undergo sp3 hybridization. Now understood? So, hope you understood how do I written the sp3 hybridization. sp3 hybridization will come only when the atomic orbitals overlap. Due to that, differences in energies. In order to make the equal energy, they combine themselves or they overlap themselves and results in a formation of sp3 hybridization. This is how, if the carbon atom is in the alkane is undergoing which hybridization? sp3 hybridization. Now, if you wanted to write the structure, so we know that this is a carbon having 3 different hydrogen atom, correct? And if you join the line, it is tetragonal in shape. Tetrahedral or tetragonal. It is tetrahedral. Okay. So, if you are writing the shape, please show the distances between the carbon and hydrogen because the hydrogen is having a 1 more electron. So, they will repel with each other. So, that we have to keep the distance. Then, we have to write this structure. So, hope you are understood with the hybridization of the carbon in alkene. Let us stick with the alkene now. I'll go with the alkene. So, the best example is ethene, which is the first member of alkene, correct? So, what is the formula? C2H4. C2H4, and you can see that the carbon is again having electronic configuration 1s square, 2s square and 2p2. In the ground state, it has how many electron? The 2s consists of only 2 electron, correct? Whereas the p orbital has a 2 electron. Now, if a hydrogen atom approaches, let us consider this is the actual structure, correct? I'll consider this is my first carbon atom, this is my second carbon atom. Now, if you see that, I have written the electronic configuration of the first carbon atom, which is having 2 electrons in the sp and 2 electrons in the p orbital. When the hydrogen atoms which is get approaches, they got excited. The excited state, what will happen? One of the electron from the s got shifted to the p and got the 4 electrons each other. And we all know that the S and P orbitals will not have same energy. They have to overlap and they have to combine. When they overlap, they undergo a hybridization. Here in the alkene, only one S and 2 P orbitals are involved in the hybridization. Hence, we call it as what? sp2 hybridization. This unhybridized P orbital, they overlap themselves and results in a formation of pi bond. That I'll show later. So, similarly for the second carbon atom also you can write the ground state electronic configuration, that is S and this is P. So, 2 electrons will be there. In the excited state, remember one of the electron from the S orbital got shifted to the P, correct? So, I undergo sp2 hybridization. This unhybridized p orbital that I am going to show later. This is how the alkene will undergo sp2 hybridization. Now, if you wanted to write the structure, this is my carbon and carbon. So which is having 2 electron. So 1 electron, this is 1 more electron, this is 1 electron, and this is 1 electron, which has been combined by an hydrogen. Here also it is combined by an hydrogen, thereby it is sharing 1 hydrogen. Correct? So it is sp2 hybridization. Now we have one more orbital, that is unhybridized. That is p orbitals which is having 1 electron. This p orbital which is get unhybridized, they overlap themselves and results in a formation of which bond? Pi bond. Okay. The remaining thing we know that in the alkene we always show with a double bond. So that is why we show with a one more bond. Okay. So this is how the remaining thing is sigma bond. Okay. 1 pi bonds are possible in the alkene. So always remember, when you are writing for an alkane, the carbon atom is sp3 hybridization. If it is an alkane, it is sp3. If it is an alkene, it is sp2. If it is an alkyne, it is okay. So in case of the sp3 hybridization, almost all sigma bond you can see, whereas in sp2 1 pi bond and remaining are sigma bond, whereas in the sp hybridization 2 pi bond and remaining are sigma bond. Okay. Hope you are understood with this. Next we are going to understand the structural representation of organic compound. There are 4 ways will be there to represent an organic compound. One is Lewis-Strauss structure, second one is a dash structure, third one is the condensed structure, and the last one is bond length structure. Let us see how do we represent with the Lewis dot structure. Okay. So this was first discovered by the Lewis. Suppose if I want to write it for the methane. So how many carbon atom will be there? Only 1. How many hydrogen? 4 hydrogen. We know that the carbon has a 4 valency. Similarly, hydrogen atom has a 1 electron. Correct? So these are sharing 1 electron, and if you show that electrons which has been shared in terms of dot, it will become a Lewis dot structure. I'll go with the alkene now, that is C2H4. So 2 electrons, and also it has been shared by this is how we can show that how the double bond will looks in the Lewis dot structure. Next is a complete or the dash structure. So after understanding with the Lewis dot structure just by writing how many electrons has been shared, now it is necessary to draw the dashed line structure just by drawing or joining that electron. Okay. For example, in the ethane, we know that the carbon is sharing 1 electron and hydrogen is sharing 1 electron. If you join these 2 lines, it will become a dash structure. Okay. So similarly, I'll go with the alkane only. Okay. I'll go with the propene. So it has 3 carbon atom. Correct. So each carbon atom which is going to share 4 electron, 4 valence electron. Thereby, you are going to join that electron which has been shared by the carbon and hydrogen with a dash. This form of writing is also one of the type which is called as dash structure. You are going to draw a line between the 2 electrons which has been shared. Next we have condensed structure. You are omitting the bonds and you are writing the structure of the given compound without any bond. Such structure we call it as what? Condensed structure. For example, in the ethane, we know that it is like that we used to represent for the ethane. Now, if you omit this bonds and if you write it as C2H or CH3 also, it is correct. Okay. You are omitting the bonds and you are going to present or you are going to write the structure of the given compound. So similarly for the ethene, it is necessary to show the double bond. Even for the ethane also, it is necessary to show the triple bond between the carbon atom. Even in the methanol, no need of writing with the bond with an functional group. If it is an alkane, you can vomit the bonds, you can write it. If it is an alkane, please show the carbon atom which is having a double bond. The later on carbon atom you can show by vomiting that bonds and you can write the structure. This is how, just by vomiting the bonds you can write the structure. We call it as what? Condensed structure. In the bond line form, in this bond line structure, the carbon-hydrogen linkage will not be shown. And the lines which are representing the carbon-carbon linkage. Suppose if you write the compound like this, this shows that here we have one carbon, here we have one more carbon like this. So it shows the linkage between only the carbon to carbon. And the atoms are specifically written are oxygen, chlorine, nitrogen, etc. Suppose if any substituent group is there, we put an dash like this, okay, or we put an line to show that there is a substituent group as there is a functional group, that we call it as terminals. Okay. Next, the line junction denotes a carbon atom bonded to appropriate number of hydrogen required to satisfy the valency of carbon atom. Suppose, for example, if I want to write the bond line structure for the propane, so how many carbon atom will be there in the propane? It is CH3, CH2, CH3. So now I start with this CH3 as with this point, okay, CH3, CH2, CH3, okay. This is first carbon, second and third. So like this, the carbon-carbon linkage can be easily observed in the bond line. It never shows a linkage between the carbon and hydrogen. Suppose if you removed one of the hydrogen and if you added one more carbon atom and if you show with one functional group, okay, CH2OH like this. How do I write? This is CH3, CH2, CH2, CH2 and this is having one functional group, correct? So I will show like this as OH. Like this, the each carbon to carbon linkage can be shown with the dashes and also which we can easily write with the bond line form. Okay. All the four representation, it is very, very important for your competitive exam, especially with the bond line representation. Okay. Next, we have three-dimensional representation of organic compound. So in this formulas, the solid wedges used to indicate the bond junction out of the plane of paper and towards the observer, and dashed wedges are used to deplete the bond which is projecting out of the plane of the paper and away from the observer. You can see that. So this is the structure of the methane. So this is a three-dimensional structure of the methane. You can see that the solid line which we can see to the observer and the dashed wedges, which has been I showed, which is away from the observer. And remaining a single bonded plane, which is also observable for the observer. This way of writing the three-dimensional form, we call it as three-dimensional way of writing with the organic compound. So in the next session, we are going to understand what is isomerism and what are the types will be there. So by this, I'll wind up this session. I'll come back with the next topic. Till that, take care and be safe. Thank you.